So we're going to continue here with the exercises for reference angles. This is exercise number 2 now. It's actually very similar to 1, except we're going to work with radians. So for each quadrant, find an angle between 0 and 2 pi radians that has pi over 3 as its reference angle. Just before we start the problem, I'm just going to flash up here our little chart where we indicate the multiples of pi over 3, right? Remember, pi over 3 is 60 degrees. And if it helps you to think in terms of degree measure, that's just fine. And so we have this way of thinking of 360 as, or 2 pi radians chopped into pi over 3 pieces, right? We get 6 pieces of the pizza here, each 60 degrees, or in terms of radians, pi over 3. Now let's go ahead and work through the different quadrants here. Again, quadrant 1, again, is just totally trivial because pi over 3 is the reference angle for pi over 3. So I'm trying to draw kind of a 60-degree angle, more than 45, right? So there's pi over 3. Pi over 3 is its own reference angle. Let's think about quadrant 2. Now, to work in quadrant 2, where we want our copy of pi over 3 is not in standard position, but with one side along the negative x-axis in this case. And so it's going to be kind of like right here is a copy of pi over 3. And so the angle we want is that one. Now, it's just like taking 180 degrees minus 60 degrees, except here we're going to take pi minus pi over 3. And to do that subtraction, pi minus pi over 3, we can think of that pi as 3 pi over 3. So I'm just multiplying and dividing by 3, the pi. And so if I think of it as 3 pi over 3 minus pi over 3, when I subtract, I get 2 pi over 3. And that's what we want. This is 2 pi over 3. So 2 pi over 3 has its terminal side in quadrant 2. 2 pi over 3 has a reference angle of pi over 3. Pi over 3 is the reference angle for 2 pi over 3. Let's go to quadrant 3. I haven't been writing my x and y. I guess I should label x and y on my axes here. We're in a coordinate system. So I want a terminal side in quadrant 3. My reference angle is pi over 3, so I'm going to have pi over 3 in that position, not in standard position. And what we want to describe is we want to describe this angle. And we can get it by taking pi radians plus pi over 3 more. And just like we just used 3 pi over 3, we can do that again. Plus pi over 3 common denominator is going to give me 4 pi over 3. So this angle is 4 pi over 3. And we can say 4 pi over 3 has a reference angle of pi over 3. I just want you to see that language too. Okay. Now quadrant 4, one more. We could have converted to degrees, done the whole thing in degrees, and then you could convert back to radians if that seems easier for you. But like I've said before, I'm trying to get you to start thinking in terms of radians without having to switch to degrees each time. So we're quadrant 4 now. The reference angle will have one side on the x-axis, positive x in this case. And so my pi over 3 reference angle is in this position, and the angle we're looking for in standard position would be that one. And so kind of similar to what we did with the degree problem, right? We're going to get this pi over 3 by subtracting from full circle, but in radians full circle is 2 pi, so we got to do 2 pi minus pi over 3 to get this angle we want. And again, a common denominator, I'm going to multiply above and below in 2 pi by 3. I get 6 pi over 3. And you know, a good little thing to know is anytime you have one of these pi fractions where the numerator coefficient is double the denominator, so 6 pi over 3, 8 pi over 4, 10 pi over 5, 12 pi over 6. Those are all different descriptions of 2 pi, right? So the pi coefficient above is double the denominator. That means 2 pi. So 6 pi over 3 minus pi over 3 is 5 pi over 3. So this angle is 5 pi over 3. Again, its terminal side is in quadrant 4, right? So we say 5 pi over 3 has a reference angle of pi over 3, and we did our 4 different cases here. So we found 4 different angles that have pi over 3 as a reference angle, one with terminal side in each quadrant. I could draw a bow tie picture. I'm not going to do that again here. Normally we won't want that bow tie. We'll just be working with one specific angle.